Now, what we're going to do is just for fun, let's go ahead and trace this on the screen so we can then do kind of a glass board thing. So, Gregory, you think you can help me trace this?
Yeah.
So here's a gigantic piece of metal that we have in the studio here. And so let's see if we can kind of trace this out. If you guys are lucky, we'll fast forward through this part so it's not as ridiculous or boring.
Let's see. If we look at this diagram very closely, we are looking for these two sides of what looks like a triangle, right? Now, turns out that I actually don't just see one triangle when I look at this. I see two triangles. In fact, we drew a dotted line here from our observation point xy. And if we notice, we can see that there's a triangle like this, right? In which one of the sides is R1, and then there's another triangle like this, in which one of the sides is R2. In fact, if we look at this line that comes directly down, is parallel to the y-axis, this is actually a right angle, and so is this angle. Okay, so this is actually a right triangle, right? And so we actually know something about right triangles that relates to sides of right triangles. We know that if one of the right triangle sides is A, say this side, right? One of the right triangle sides is B, right? And these are the two sides that are not the longest side, called the hypotenuse. We know that we can relate those two to the length of the third side, the hypotenuse, which is C. Okay? And that relationship is A squared plus B squared equals C squared. All right. So if we look at this right triangle right here, let's actually see if we can sort of identify which sides are in RA, RB, and RC. Okay? So if we look at this right triangle, we can identify the longest side is actually this side, R1, which is actually what we're looking for, right? So that's R1 squared. Now, turns out A and B, the choice is arbitrary. So let me actually go ahead and choose B to be this side. And as we can see, this side, the length of this side is actually the height of our point. It's kind of like the height at where our microphone is placed, right? So B is actually just equal to R, or Y. Okay? Now A is this side. Okay? Let me draw that a little bit more cleaner, like that. Okay? So looks like if we look at A, it apparently is not, it's not something that's cleanly labeled. So we're going to actually have to look at the geometry a little bit to figure out what that distance is. So let's see. We know that this here is the origin, right? This is where x and y equals 0. So we can just go ahead and draw a little 0, 0 over that point. Okay. Now, that means that this distance from here, which is directly below the origin, to here, this is actually x. Hopefully that's clear to anyone. And if it's not clear, pause this video and look at it for a little bit and think about it. So that seems to imply that this whole length here, which again we're calling A, is actually equal to this distance x plus this distance here, which actually we do have labeled as d. Okay, so that's supposed to be A. Let me draw that a little bit cleaner. Sorry. Okay, and so we can clearly see then is A is equal to x plus d. It's the addition of those two lengths. So we can go ahead and put this up in this equation up here. And what we see is that we have x plus d squared. Okay? So that actually gives us a nice expression for R1, this distance here. Okay? Now, we want to also find out what R2 is. And actually, this is also a right triangle. So we can use very similar logic to figure out what R2 is. Okay, so let's look at, let's erase this so it's clean up a little bit, and then we can look at R2. So let me do that really quick. Okay, so once again, we have a very similar situation. It's a right triangle, right? We have to identify sides. Once again, our hypotenuse is this side, okay? So kind of ignore this half of the triangle, just look at this tiny sliver over there. And this side is our longest side, so again, we identify that as c squared. So we have R2 squared, okay? We're substituting R2 in the c right there. This again is going to be our b side, and this down here, this sliver is our a side. Okay, again, hopefully it's clear that we're identifying kind of like this small length right there. Okay, so we need to identify what b is, and we said that that was actually y, very similar to this triangle here. But now we have to figure out what this small length is here. Okay, so once again, we sort of have to look at this diagram to kind of figure out what that length is. And here's something that you should note that should help with this. Notice that this distance here is x. Remember, we used that in the last step, right? And it so turns out that this distance plus this small distance, which is what we're looking for, is actually equal to d, right? They kind of like added together, they make up this side, like this half of the axes, right? And so what you can identify then is d is equal to x plus a. It's kind of like the inverse of this one we did over there, right? But now we can solve for a. So if we actually subtract x from both sides of this equation, we see that that implies that a is equal to d minus x. Okay? So let's go ahead and put that as our length here. Okay? Now, just because I like symmetry, I'm going to invert this and pull out a minus sign. So it's minus x minus d. So we're pulling out a -1 right there. Make that a little bit cleaner. Okay? And so we can distribute the powers. Hopefully you remember that from your algebra class. But -1 squared is just 1. So essentially it's, we could have written the minus signs either way on that. So let me move a little bit so hopefully you can all see that. Okay, so there we have an expression for R1 and R2 squared.